Machine learning is a process of training a machine with specific data to make inference. We can deploy machine learning models on the Azure cloud and integrate ML models with various cloud resources for a better product. In this video, we will be covering COVID-19 healthcare scenario, classification model, creating Azure Machine Learning Workspace, creating classification training pipeline with Azure Machine Learning Designer, and deploying the training pipeline using Azure Machine Learning Designer. Please check the description below for more information. In the end, we will also share details about the Azure Data Scientist Masterclass, which will not only help you understand basics, but it will also give you an idea of the learning path to follow. It would be helpful, especially when you're preparing for Azure Data Scientist certification. That's designing and implementing a data science solution on Azure, which will earn you Azure Data Scientist Associate certification. Welcome to another episode of Azure video series from K21 Academy, where we take you from complete beginner, covering no-code machine learning to all the way training models, including running experiments, monitoring, and working with data, as well as how to prepare for the Microsoft Azure Data Scientist certification. We have taken a clip from one of our certification training program on designing and implementing a data science solution on Azure. That's DP100. And in this clip, our Microsoft certified trainer will talk about training and deploying a classification model based on healthcare scenario. So, this is a clip taken from a module on no code machine learning with designer. Now, let's hear from an expert trainer on the same.
So this is a scenario which we are facing really these days during the COVID-19 crisis. The problem is that we have huge number of patients as such. Now, when we talk about huge number of patients, we really have the people who are sick, who really need help as well right now. A lot of us are healthy, and precautionary measure, we go and we do the health check. We want our COVID-19 testing to be done. So when we talk about huge amount of patients, we have both type, healthy, unhealthy, and we might have some other cases as such where the person is not actually having COVID-19 or they are not infected right now. Maybe they have some other problem, and because of that, they are going to get the testing done. Now, one of the problem we are facing in the world is that our health services, we have less number of doctors, we have less number of those advanced testing facilities where we can do those testing, and we have huge number of patients who are coming in and who needs the healthcare right now. We have limited number of hospital beds, we have limited number of nurses, we have limited number of oxygen cylinders, and so on and so forth. Ventilators are limited. We need to find one solution for it. So the solution comes in terms of machine learning, it comes in terms of classification, it comes in terms of screening the patient at the right time using various data points, and once the patients are screened, then we provide them with the correct services. So the scenario is of a healthcare service, right? So let me run you through this again. So we are talking about healthcare. A lot of patients are there and they all are looking for testing, and we have less number of doctors. So what can we do, right? Check this out. So over here, now one of the things which we can do, so now I'm starting directly from the scenario itself. Why I'm starting from the scenario itself? Because scenarios generally make more sense, and even if you're a beginner, you will come to understand that we have a requirement over there, and how can we do it? That part I'll practically show it to you. Notice this now. So what we can do, we can have a classifier over here. What's a classifier? Classifier basically classifies the input data into some outputs as such. So whatever patient, X number of patients are over there. Now, how will we create this classifier? That's the practical part, which I will show it to you. So we will be using some previous data on which we will be creating that machine learning model as such, which will act like the classifier, and in this scenario, which will act like the screening layer. So all the patients, when they are coming, we will pass their data inputs to this model, and this model will be screening them and will be classifying them into some output categories. So what are these output categories? For example, we have sickness A, these X number of people have this problem, these are healthy, they can go back home. Sickness B, sickness C, and so on and so forth. So imagine this is the red, the marks which I have done in the red part over there. These are the people who really need the COVID-19 healthcare right now. They require advanced testing as well. They require the doctors as well right now. We don't have a medicine, but we definitely have the precautionary things we follow. So these people, we can say that, okay, we have done the initial screening, And in the initial screening, whatever outputs are coming out, only those people will be going for the advanced testing. Now, what do I mean by advanced testing? You all know that when we do the COVID-19 testing, it takes time to do that. It's not like a right away process, it takes time. So we are trying to reduce the number of, or you can say we are trying to reduce the pressure on the testing facilities as such. How are we planning to do that? Notice this now. So what are we thinking that, okay, we have huge number of patients. Let's do a screening first. And in the screening, we'll put a classifier. What's a classifier? Classifier is as simple as something which classifies the input features into some output categories like that. So that's what classification does. Now, classification can be binary classification, meaning I have diabetes, I don't have diabetes, 2 classes, or it can be multi-class. So in the screen right now, I'm showing a multi-class classification. So it can be binary, it can be multi-class, right? More than 2 classes, it also will be there. So now one of the question which you should be thinking, or the right question to think right now, is that, okay, so the model we will be training with the previous data. That totally makes sense, that's fine. How to do it, we'll see it, right? But how are we gonna do that when the patient they really come? How are we gonna do the testing, or how can we make this like a practical scenario? So what are we planning to do is that we know that whenever COVID-19 patients are there, they particularly have a type of X-ray through which we can also classify them. And if you are living in any country, what generally in any testing facility, it's like generic testing facility, they also have X-ray facility over there. And X-ray you can do within, you can say in 1 hour, you may be able to, the technician over there, we don't even need any a doctor as such over there. Any trained technician can take out an X-ray within, you can say in 1 hour, might be doing 60 X-rays as such. So we can improve the number of X-rays which are being done. So the patient can go to any generic testing facility in the locality, and they can just get their X-ray, and that X-ray they can upload, or you can say upload in the sense when we will have a, you can say when we will have a web service, which we are talking about in the demo. But or they can simply put that against that model, and that model will classify them. Okay, that looking at this X-ray, you seem to be having a high probability of having COVID-19, or you're infected right now. So because you're infected, others are healthy, and you are infected, we can send you for advanced testing. So I think it's classifier written over here. Hopefully that something got missed. It's a classifier, right? As such. Now check this out. So data is not a problem. We are generating huge amount of data. That's all data science is about. Huge amount of data, machine learning, training that models over that huge amount of data. Data can also be coming from your Fitbit devices which you have. The data can also be coming from the insulin pump which you have. Data can be coming from mobile devices. Data can be coming from all these type of sensors which we are working for. So let's talk about this. How will we practically do it? So I hope the scenario is clear. Let me know if there is any problem with the scenario. Please just shoot with the question, and I'll explain the scenario again what we are doing, right? So guys, check this out. So we are trying to thinking of making a classifier. Why do we need the classifier? So we can screen the patients, and once we have screened those patients, we will be only taking the further, you can say we will classify them as, okay, you guys are high risk, you can further go and get the advanced testing. So there are hundreds and hundreds of use cases where we can apply that. Now check this out, what I'm gonna show, exact same thing I'm gonna do. So let me explain these steps which I'm doing. I'll show you one more time, don't worry, right? Hang in with me. Maybe if you feel I'm going very fast, being a beginner, but even in that scenario, the scenario will be clear to you. You will be able to understand what we are talking about, right? Maybe if 100% of absorption is not there, but still you will be able to understand what we are talking about. So I have a data set over here. So this is a real data set as such. This data set is available, it's called as PIMA diabetic data set. And this is diabetes data set over there. And in this example, we are using diabetes data set. So what classes do I have? What are these? It looks very scary right now. This file, it's available online. So I will be importing that particular file, but I just want to show you the data set before. How does it look and feel like? So this data set is available on a link as such, and you can see it's hosted on GitHub in Microsoft repository, and it's one of the lab as such, which if you are going for DP100, you will be doing this lab yourself, and you will be able to learn the classifier part of it. So this is the data set. We have various classes over there. So this same classes, you see the first row as such. This thing I have listed over here in my diagram as well. Notice this now. So let me just move that to my secondary screen. Okay, that goes away. Check this out. So how do we train that classifier? We get the data set first. We get the previous historical data set from hospitals. You need to have the factual data set. Do I need huge amount of data or do I need small amount of data? It depends on the type of algorithm which you are running, right? Sometimes we need good huge amount of data. Sometimes we do not need that. Now, secondly, is suppose the data supposed to be of good quality? Yes, obviously the data will be, we are trying to gather data which is as factual as correct as possible. This is supposed to be ground truth. It's supposed to be correct. So we gathered the data, and the data set which we are using, that data set we have gathered from the hospitals itself. There are multiple columns over there. What are these columns? We call them features as such. So multiple features are there. And whose features are these? These features are of the patients which are going over there. Like what feature can be of a patient if we think about that? Age can be a feature. Whether body mass index can be a feature. Insulin level can be a feature. Tricep thickness can be a feature. Blood pressure, glucose level, number of pregnancies can be a feature. What is diabetic pedigree? So this diabetic pedigree basically means in your family, if you have a history of diabetes, how much your family history is going to affect your scenario right now. That's what that function gathers. So we have this data set, and so we will come to Azure now. So we need somewhere we can train these models. We need somewhere we can have the big compute. If you have huge amount of data, you need big data clusters. So you need a place. You cannot run the big data cluster in your laptop itself. It's a pseudo node. You need a cluster itself, right? So the first thing which I will be doing is I'm going to import that particular data as a data set. What is the meaning of data set? It's a term I'm introducing right now, and just remember the term just like that. In Azure, we have a concept in machine learning called as data set. We import them. Now, once this data set is imported, we will be pulling that data set into our experiment pipeline. A lot of questions will be there. So just hang in, listen to the scenario, and I'll practically show it to you, right? Then your questions. Check this out. So we import this data set. And now once we have this data set, we will be doing some steps on it. You can see some steps I have drawn in the diagram. So what are these steps? Well, let's do it till this step. Let me quickly show you how to make the machine learning service. In the meantime, you will get some time to absorb it. Then I'll show you the rest of it, right? We will talk through this particular scenario. Check this out. Let me take you to Azure portal. And now I'm just gonna drag the browser. So this is Azure portal. You definitely need one Azure subscription. Once you have the Azure subscription, how can you get the subscription? You can go for a free trial as well if you're doing the preparation right now. And once you have done that, you will search for machine learning in Azure subscription and click on create. And it's a simple form you have to fill up. So just give your resource group over here. I might be having some existing resource group. I can select that. I can make a new one. Let's give it a name over there. So this is Shivam's ML service demo as such. Let's say demo as such, or let me say 2. Which location I want to deploy? Southeast Asia. What workspace edition do I want? Enterprise. We might be doing this in production. We need enterprise. Let's click on create. So let's click on create one more time. So this is as simple as how you can have a place where you can run your entire data science life cycles, right? So we deployed something. So I'm very conscious about your time. So I have already deployed this before. So once this is deployed, it will take hardly 2-3 minutes for it to be there. But let me show you the one which I have deployed like an hour before. So you will see if I click on all resources, let me click on resource groups. And the one which I deployed before this is called as Shivam's ML service 2. Okay, that's also 2. And click on launch. Once you have this service launched, we click on it. And this is the machine learning workspace. So once I click on launch, this page opens like that. What options do we have over here? Let's have a look at these options. We have some notebooks, automated machine learning. In the previous webinar which we did, we talked a lot about automated machine learning. Right now we are more focused about classification. So the rest of the things we have already previously covered, and in future we can cover in a different day. We have a designer. We will be using it. The first step is data set. So we click on this data set option, and it's asking me to authenticate one more time. So let it authenticate. That's totally fine. So the browser actually automatically refreshed. That's fine. Okay, now check this out. So the first thing we're talking about is we have to import that data set, right? So the data set might be available in a SQL server. Data set might be in some sort of web location. Data set might be in HDFS. Data set might be anywhere. So I'm just going to copy that particular URL. I'm going to give it over here. And let's say this is the one, and I give it a data set. I say 2, and it's a table which I want to be imported. I say next over there. So what I'm doing right now, I'm importing this data set, which is available on a URL into my workspace. Then I will be designing the rest of it, the gray part over there. Hang in with me, right? Check this out. So if you see those who work in data science, the first problem we saw right now is that when we imported this data set, the first row is not actually, it's the column headers. So how can we do all this basic transformation? We can simply click over here. We can say, okay, the first row is actually the header. It's not the first row itself. You imported it wrong. Now it's correct. So I have patient ID, pregnancies, plasma, glucose, and so on and so forth. I'll show it to you. Let me import it first. Now, in case you don't want any particular column to be not included, you can simply untick it and you can go ahead with that. Right now, I'm going to let it be default. Just say next and just say next after that. So what is going on right now? Data is getting imported from that particular location into my machine learning workspace. If I click on it, let's now talk about it. And if I show you, if we explore the data, let's click on it and let's explore the data slightly. So we have exactly 10,000 rows. We have 10 columns over there. The first is patient ID. It's not relevant right now. Patient ID is basically some sort of patient primary key or unique number in the database. Number of pregnancies, it's very self-evident what that is. Glucose level, blood pressure level, tricep thickness, insulin, BMI, my family history, and so on and so forth. Age, and the last column is the one, diabetic or non-diabetic. So what is the meaning of this? This is supervised learning we are talking about. Meaning that in the original data set, I already have what I'm trying to predict. I have the label over there. So in this diagram, where is that particular step which we are doing? So if we go quickly back to the previous one, it's already over here. Let me just switch as such. Notice this. So what are we doing right now? We got the data from hospitals, and now we are trying to, let's go down, right? Check this out. So we got the data from hospital and we are trying to train that model. So in this scenario, we already have the patient records with us. We know that on which scenario, on which feature, which patient was diabetic or non-diabetic. So we have that data. So we are training that particular classifier. So that's why in the data set is supervised learning, we have that particular information as such. Notice this, let's carry on. So I have this data set, 0 as self-evident, 0 means non-diabetic, 1 means diabetic over there. So this is previous data. Now let's import it. I'm clicking on the designer preview. Now first question which I get is, do we need, what programming language do I need to know to do machine learning? Now machine learning, if I talk about that, we will be needing some sort of, we can say Python, R are the go-to ones. If you work in Azure, you can use anything. You can use the designer, you can use Python, you can use R. It's all, anything is recommended as such. There is no downfall of anything. Now the data set which we imported, I'm just going to drag and drop it over here, right? It is asking me if you, some of you must have seen some red thing was there on the right side. That's okay. That's totally fine. So this is my data set. I just imported that into my workspace. Now what am I talking about? Before I can show you that, let me quickly show you one more section over here, which actually I skipped. Notice this. So I've changed my browser, right? Tab. Notice this. Now we have various type of compute instances. Those who are preparing for DP100, they will, and those who have prepared over there somewhat, you will know what I'm talking about, right? Compute instances, clusters, and inference cluster. So what I'm doing right now, once my model is trained, I will be deploying my model into Kubernetes. So on the right side, I have Kubernetes, and this is where the model is deployed, and any mobile application can do a API call with this model and can get the score back. What is the meaning of inference pipeline? Inference pipeline basically means that how my API data is going to come in, and any transformation which I want to do on it. We'll come to it. Hang in. What is the meaning of compute cluster? Compute cluster basically means it's the location where we will train this model, right? So that's the compute cluster. So do I need to make them first? 100% we need to make them first. So notice this. The very first thing, I already have them running because they take 2-3 minutes to come up. So I already created them. But how can you create a new one? Just click on this option, give a name, and what is the exact meaning of these instances? I'll help you with that. Just give a name, say create, and in next 2-3 minutes, this will be running, right? Check this out, guys. So once I have the data set, now logically also, if we think about that, once I have the data set and I imagine you created the model, let's hypothetically you created the model, the machine learning model, don't you want to test it out? So if you create the model 100%, you will be testing it out. So we will be having some sort of training data set and a testing data set where we can do the testing part. Those who are coming from any mathematical background, or let me just be very uh, high level introduction to what is pre-processing of data. So the data set which I have right now, I want to do some pre-processing on the data set. In machine learning terms, we have a thing called as normalization. What is normalization? The word might be very new, but normalization basically means that I'm doing a normalization called as min max over there, which will rescale my data into a new scale. Meaning of that is that in mathematics, if I have a very big numeric value, that can affect the model training. So I don't want that big numeric value to be there. So I normalize, I rescale that value between 0 and 1, and I just change the scale over there. What's the meaning of it? In a very easy layman term, you can take the measurement in kilometers, you can take the measurement in millimeters, or you can take the measurement and so on and so forth. I'm just changing the scale over there. Once the scale is changed, we will split the data set. What's the meaning of split the data set? Let's use it. So the data set is coming from here. We change the scale over there. We rescale the value between some smaller terms, smaller ranges, and then we split into 70%. So 70% of data is going on the right, on the left hand side as per the screen, and 30% of the data set is going on the right hand side over here. With this 70% of the data set, I'm going to train one model. What is the algorithm which I'm going to train? This part I'll show you in the slide deck, the algorithm as such. And this algorithm is called as two-class logistic regression algorithm. What it does two-class classification. Like it will tell you whether you have diabetes or whether you are non-diabetic as such. So once we train this model, this is where the model training happens. And this is where we do the testing or the validation of the data set. Whatever we trained right now, we are checking whether it did a good job or not. If it did a good job, we can further deploy it. If it didn't do a good job, we can further make the improvements. We can change, we can gather more data, we can change the data pre-processing, we can change the algorithm, we can do many more things, hyperparameter tuning and so on and so forth. So this is where the testing is going on. We test it out. And once we test, everyone wants a report, right? So this is where we are getting some sort of evaluation matrices out of it. I'm using a very simple word as report. It's evaluation matrices, that whether it's accuracy or how good this model did. So let's do it the same way we talked about here. Let's understand one more time. Just hang in for check this out. So let's go back to the designer, and I think I already clicked on it, so it should be this one. Hopefully, check this out. So the data set was already dropped over there, and I'm waiting for my browser to load. Great. So it's asking me that, Shivam, where do you want to train this? I want to train this over there. Where did I deploy it? I deployed it before. Now the second step, I want to do some sort of normalization of data over there, meaning I want to change some scales. I quickly search for normalization, I drop it. So now those who are asking, is Python the mandatory for me to start? You can definitely start from the designer part as such, and in future, once you get expert level, you get comfortable with Python, you will become even faster. So from GUI, sometimes we are not fast enough. We can do a lot more from Python as such, right? Is this having any downfall, anything negative point? No, not really. So I'm adding all the columns whose scale I want to change, and I'm just adding it and just say save over there. I can run it right now, and now I want to split my data set. What is the purpose of splitting the data set? We want to make two data sets out of this single one. With the 70% of data set, we will be training the model. With 30%, we will be validating that model. So I'm saying .7 over there. And what is the meaning of this .7? Basically, 70% will go on the left-hand side, and the rest will go on the right-hand side. You see that I have two outputs. Hopefully that is visible, right? These two outputs. Okay, now check a couple of more things. Let's train the model. So I'm going to drop this train model, and I drop it like this. Which algorithm am I going to train right now? It's called as two-class logistic regression. Those who are preparing for DP100, you guys will be using it, logistic regression, for classification purpose. So I drop it over here. Why is this red mark coming over there? So basically it is asking that, Shivam, you forgot to provide on which, what do I have to do? So this algorithm is asking you right now that what do you want to do? Meaning you want me to train and learn some pattern between X and Y in features and the output. You want me to learn that function, but what is that Y? What do you want me to learn? So actually I have not given the target attribute. So I want this to learn on, let's say I have one column over there called as diabetic. Let me call it copy the name, and let me show you. And that reminded me to show you the visualization feature as such. And let's load. And we are waiting for it to load those. Oh, okay, that's amazing. Check this out. So in case I want to visualize something, I want to see whether some dates, some value is missing and so on and so forth. I can click on these outputs and I can check whether what's the distribution of my data set, what is the minimum value, maximum value of my data set. And if I think about age, let's say what is the minimum patient attribute over there and what's the maximum age of the patient which I have data set of. So all these things we can take from there. I just wanted to copy this column name, which I should have copied before. And I'm just gonna give it over here, right? So what I'm doing, I'm simply saying that you have to learn how when the input feature comes, how what is the mapping between input features and being diabetic, like that, right? And as simple as that, let's drop the last two. So let me just quickly search for score model, and one last thing, evaluate. So like that, let's finish it up, right? Right, so guys, so what we just did, there is a compute cluster right now. I just clicked on train, and that training is going on a 2-node virtual machine cluster which is CPU based. So there is a compute cluster. Now this is different from a deployment cluster. There is one more thing called as deployment. So what is Kubernetes? It's an orchestrator for containers. It's amazing, and basically my model will be finally deploying over there. So your Kubernetes is the deployment target where in production it is deployed. Right now I'm training on a 2-node compute cluster. I will show you the entire thing, right? So notice this. So once model is trained now, it's already trained. You can see it's all the green parts are there. How do we know whether it's doing a good job or not? First of all, how will we see the outputs? We can just right click and see the visualizations like that. So over here, what is going to load? Basically what my model is saying right now. Please notice this, right? So actually, so we are doing the testing right now. In the testing, how do we do test? We already know the answer and we are asking the model that you tell me the answer. If the answer matches, that's a correct output. So actually this was supposed to be the answer and the model is saying 1. So it's a misclassification right now. So this is the scored output. So scored output 0, actual answer 0, that's perfect. 0, that's perfect. 0 answer. Model said 0, you don't have diabetes. Actually the patient didn't have diabetes. Model said you have diabetes, and actually the patient also have diabetes. So I have 3000 rows. I cannot just go and check my model output like that when it did the classification correctly, when it did the misclassification. So what do? I need some evaluation reports. So I can simply click on the evaluate model, and over here I will be getting some accuracy as such. What is accuracy? Accuracy basically means all the questions we asked, how many questions it correctly answered. So you will see some sort of matrices will be there, and those matrices will be where we will have accuracy. So let it load, and in the meantime this is loading. Check this out. So once this is trained, we can deploy this. With one click you can deploy this, and once you have deployed, with one more click you can deploy in Kubernetes. So I have already done that part. I will simply show you how it can be done, and if you're thinking about how it can be done, I'll show the steps as well. Notice this. So right now my model is saying, so if you check this out, this is called as confusion matrix. It's a crisscross matrix and it's a very simple one. Over here we have the model outputs. This is actually what it was supposed to say. We are testing it right now, so we know the right answers, right? So when the patient had diabetes 616 time, so when the patient had diabetes 616 time, it correctly predicted diabetic. When the patient didn't have diabetes 1755 times, it did the correct prediction, and all the others are misclassification. And what do you do when you don't know something? What do? You learn more. So we can get those data set, we can get those inputs, and in the next data science life cycle, in the next training cycle, we can provide the data and improve the performance. What is my current accuracy? It is coming as 70.79. In percentage, it's 79% accurate, right? That's accuracy comes like that. How can I deploy this model once it is ready? So I can just zoom out first and click on this option, click on real-time pipeline. So this part I have already actually clicked here. So it takes some time. So I already have this ready as a backup in case the demo breaks, right? Check this out. So what is going on? My API data will come from here, right? This is where the API call will come in, and this is where the API call will go out. Any transformation which I want to do on that particular this. So what is this pipeline about? This pipeline will be the pipeline when we deploy this in production. How the API data will come in, if we want to apply some transformation on that, or if we want to run some Python script on the data, if I want to make any changes in the output and so on and so forth, I can provide all the details as such. And afterwards, with one click, I can say deploy. And on this deploy, where do I want to deploy? So I can say, okay, this is my test deploy during the demo. Let's say test 2. Oh, it's asking don't give capital and so on and so forth. So let's not give it like that. Let's say Shivam test AKS. Now I want to deploy this in Kubernetes cluster, which I created before. I click one and it's starting getting deployed. So it will take some time to deploy. So what I did, I already did it for you. There is no other step as such. It's totally, it's a very good service for data scientists where they need not be an expert in Kubernetes, but it just got deployed in Kubernetes. Once it is deployed, it will show in endpoints. This is the one which is we just deployed. This is the one which I deployed 1 hour back. When you guys were introducing, I did it there. Now check this out. If I click on that endpoint, I click on consume option. You see this URL and you see this key. This is the key the developer will be embedding in the mobile application. This is the key which the developer will be embedding in those UIs in the front end or in any software which you create. Those URL and the endpoints are those are the API authentication. You can say the endpoint where the call will go, REST endpoint, and it will be signed by that particular key. Can I show a testing to you? So this is where I have one Jupyter notebook open. And what I did, I just copied that particular endpoint which I deployed over there, and this is the key, right? So this is the endpoint and the key, and basically we are saying that there is a particular patient ID. So what is going on right now? This is real time. When the patient from his insulin pump, or maybe he's having an IoT device at his home where locally he just checks for some sort of testing, and the data goes from that particular, does the reporting, and the output comes out. So whatever in real time in production will go, it will be having a structure like that. And what is this piece of code doing? It is simply doing an API call, and the output comes like that. So you can see that the patient number, this is having prediction is 1. 1 means that this person is diabetic, and the probability output of this prediction is 0.68, right? So let me just revise what I just showed you. Check this, guys. We had the data set. We broke the data set into 2 pieces. With one data set, we trained that model. And this is behind the scene happened. Right now, we will not be talking about sigmoid function, but you need to know that in case you go for the certification. So there is a threshold line, and on the y-axis I have probability, on the x-axis I have all the features. This happened behind the scenes, right? So what happened with the training data set? That particular, you see the dotted line as such. This dotted line is sigmoid function. This sigmoid function is that mapping which got learned from x to y. And once that happened, we did the testing with the testing data set, and the model either predicted correctly or did the wrong predictions, and we understood that correct or wrong predictions in a confusion matrix, which showed us how many correct predictions are there. These darker ones are the correct predictions, others are the misclassification. Once we have misclassification, we gather more data, improve the performance like that.
So, that was a clip taken from one of the lessons from our step-by-step training program on Microsoft Azure Data Scientist. That's DP100. I would like to invite you for a free 90-minute session with our Microsoft Certified Expert Trainer, where we talk about the Azure Data Scientist training and share information about getting certified by using our step-by-step roadmap to go from complete beginner to a certified Azure Data Scientist. If you are interested, register for a free class by going on to k21academy.com/dp10002. Additionally, we will show live demo predicting diabetes in patients using machine learning. We will also share information about the certification exam. So you can register for free by going on to this URL k21academy.com/dp10002. I will see you in another episode of Azure video series from K21 Academy. Till then, take care.